Hello everyone, this is Mr. Ege and I'm working on today we are all working on the second part of the video demonstration that we are creating an assembly drawing in order to launch the rocket in particular place with a certain initial velocity and there is going to be a simulation creation at the end of this video. And first of all, we need to start a assembly drawing, and the assembly drawing will be, we're going to set it up to metric scale and set the units to millimeters. And after that, we're going to place the assemblies, the parts. And those parts, when they're assembled together, then we're going to use the simulation. Okay, so start your inventor, please. And with the new command, you need to go find the new assembly. Click on that in front of your inventor. New assembly, okay. We'll just start in a second. This particular startup procedure with the button is easy, but then it becomes a little bit more difficult if you have to change your units. With the new command, it will be much easier, but we didn't do this way. This time we just simply clicked on the user interface, easy user interface, okay, assembly drawing, and now we need to set our units to metric and millimetric system, okay, more specifically. We don't want to select the meters, we want to select the millimeters, all right? For this, we go to Tools tab, okay? And Document Settings, click on it also. Select your units, and it's not each system is going to be millimeters, okay? And mass, pounds, we're going to change the pounds to kg, kilogram. Okay, kilogram is the metric system, millimeters is better. Time is for seconds is much better right now at this time. We know that the 1 millimeter is equal to 1,000 millimeters, so we can easily convert the meters into millimeters without any difficulty and apply. Cool. Everything is done. Now we can close it, okay? And now we're going to go to Assemble tab and Place. And what are we placing? We're placing two things, okay? One of them is the Beyond Mars part drawing, okay? And another one, the launching pad, okay? So we need the launching pad also, okay? And click. And it did not like the location of place where I saved it. Okay, I saved it in a better location. Actually, it's right here, Mars drawing. Okay, this is the part drawing, and I'm opening this one. Okay, this is the Mars part drawing, and all we need is just one, so escape. Okay, and now we need to place a launching pad. And launching pad is something very easy. It's an oval that's extruded about 1 meter or so, and if you don't have it, you can make it very quickly. I can demonstrate also how to do it from inside the assembly. But normally IPT part drawings has to be done individually. Normally, okay. Click on the place button, and because it's so simple that I'm not going to demonstrate how to do it right now. This is just an extruded oval, okay. So I'm going to just again go back and select launching pad. Okay. And place it. Okay. escape key. Now we only need one launching pad. Okay. Launching pad needs to be rotated. So if you click on the launching pad and then press the right mouse button on it, okay, there's a free rotate command that enables you to change the launching pad, rotate the launching pad, so that is perfectly horizontal. Okay. Now click on it, right mouse button and free move command, and then you need to move the launching pad below the rocket, reasonable distance. I don't want to put it right underneath the rocket because there's a process that I'm going to link the relationship between rocket and the launching pad that requires me the view of the, and I'm going to just simply switch to the top view to see where the launching pad is. I'm going to just kind of center it. Okay. I think we're in good shape now. And now I'm going to save. Before I save everything, launching pad, let's make sure that launching pad is grounded. Why? I want the launching pad grounded because it's not going to be moving any place. That's why. I want to build the rocket not grounded. Okay, that's very important part of the process. And I'm keeping the rockets a certain distance up for my own convenience of the operations. Actually, you can put it down on the launching pad if you like, but it's going to be difficult to access both launching pad and the rocket. So that's why, for convenience, I put a distance over there. Okay, and once we got launching operated, we can remove the distance in between if you like. All right, saving is important part of the assembly, and once you accomplish something, always go to save as. Okay, and I am putting it under the rockets folder, and it seems to be working. And this is Beyond Mars assembly, so I'm going to call it Beyond Mars. I have a tendency to write names capital letter in capital. All right, let's see. Good. So we placed these two items, two parts separately, but we changed, launching pad is grounded so that it doesn't move. And now both of them has to be selected. I'm making and pressing the left mouse button and making a selection window, including both parts. Okay, this way they're all selected when I make it big enough, and it shows me, computer shows me in turning everything in blue. Now here, one thing I like to do, I want to go to the environments, and I want to start a dynamic simulation. This selection activity I just did, okay, literally included two entities into dynamic simulation. One of them is going to be moving, the other one is going to be grounded in one place. So now a computer knows what I like to do. Okay, also there's my browser on the left side changed its view. Now I have external roads. Okay, Beyond Mars is showing up here, and the launching pad is showing up here. Initially, they both seem to be grounded, but I know that the launching pad is grounded, Beyond Mars is not grounded. Okay, external loads, there's only gravity, and I'm going to press double click the gravity to just test it, to see what it looks like. I want to show you. This is an entity gravitation, and it's 9,810 millimeters per second, which is correct. Okay, it's normally 9.8 meter per second square. Okay. I like to see the vector component. I see the vector is placed upwards. It should be down. And that's why I'm going to change this number. Direction is different. It's wrong. It should be in the y minus y. And so there is, that has to be adjusted, okay? If I go to entity selection, all right, and select the entity based on, and add the numbers to minus, it should be downwards. So that's why I added. Vector is important. I'm keeping the vector, and direction is minus y, 9,810 minus 9,810. Okay, it's in the y direction. Okay. All right, it's correct now. And enter. Okay, so down arrow demonstrates. So the pull, it's a gravitational acceleration is actually, even though it's an acceleration and it is units are meter per second, is also what pulls down the rocket, and that's why we need an arrow indicating the right direction of the operation of the force. So we're going to treat it for practical reasons as a force, okay? And even though gravity is actually the acceleration, because of the gravitational acceleration, it happens. So, okay, all right? And now this is done, but there are other forces too, especially the rocket's its own engine. So I'm going to click on the external loads on the upper and press the right mouse button on the project and add a force, okay? And this is critical because I need to add a force at the bottom where the engines are, and engine is here somewhere around here. And so location-wise, click on the location, move your cursor, and I'm gonna select faces. So move my cursor, select the faces around this edge, okay? And enter the number 2. That's very, and I just did the mathematics on this one, and it's a huge number, 100 billion newtons. Okay, so 100, then million. No, is it billion? No. Yeah, 100 billion. And 1, 2, 3, 1, 2, 3. This is a huge human-sized, life-size rocket, and it's 50 meters high, so it needs so many newtons, 100 billion newtons. I'm sorry, 100 million newtons of force pushing it down, okay? And I would like to see if I can the force over here, okay? Again, it's in my y direction, and it's It's pushing it up 100 million, 6 zeros. Okay. Newtons of force. And it's already selected. Good. Okay, so now we're going to see if it's going to be working or not. And we always have to test it, how it is. So I'm going to just go click on this one and nope, it didn't work. So we're going to have to do a few more times, and also the timer is extremely slow right now. I'm going to just change the timer 100. Okay, seconds. Okay. External loads is not, even though I added, it didn't show up. So add a force. Okay. And okay. Okay, so this is an up force, and I think it looks good. Now we're going to apply it. Okay, this is we have a good chance to, and then we're going to need to test this. Okay, even though it shows up, the force that I added shows up. It is not moving the engine. And we may have to modify it. Okay, so one thing important that we have to establish the relationship. We mentioned it before, and the relationship comes from the insert joint here, and insert joint we have a spatial joint. First component is the moving component, so that's why we need to select the element, which is rocket. Second component is the launching component, launch pad, and apply. And that is essential that we have this, okay? That this establishes what is moving and what is not moving, okay? So external loads are still there, and now we're going to have to test the launching simulation. And it is moving right now. Gradually, our rocket is moving. Now, link is most important part of the equation. As soon as you have your assembly ready, the simulation player requires a link established between the launching pad and the rocket, number one. Number two, you have to add the forces, make sure that the gravity is properly placed, and also the force that's going to apply the rocket to go up a certain distance. Okay, so apparently this seems to be working. It's not going too far up. Okay. It already stopped. So what can we do about this? Okay, so click on the, and we're going to go to mechanics. All right, increase the force by 10 so that it's not 100 million, it's 1 billion. Newton. 1 billion. So that 9 zeros. Okay. And okay. Direction is correct. And let's see if it's going to go higher. Yes, it's capable of moving much higher than it, and faster too. And I am pulling with my pen, pressing down the mouse. Eventually it's going to stop at one point because, yes, the force that is applied to the rocket can take it only so much higher. Okay. Okay, we can literally calculate, okay, the initial speed, the velocity, based on the distance that it went up. Okay, all right. I suggest you to please go ahead and do what you can do up until this point. Okay, please remember everything we did so far. So I'm going to just summarize it. Okay, first of all, we started an assembly drawing. Okay, and then we set our units to millimeters. Okay, and then we placed two part drawings. One of them is rocket, the other one is the launching pad, which is you could make a circle and extrude it a little bit in a different part drawing, or you can do it from inside the assembly drawing too. You need two parts basically. One, the launching pad, and another one is the rocket itself. And then after that, we need to select these two items, okay? And under the assembly, after selecting these two items, like this, you can literally go to environments and you can dynamic simulation. Once you start the dynamic simulation, computer gives you a chance to change the relationship. So you select the link, dynamic simulation started, okay, and insert a joint. Joint, okay, requires you to select the moving part first, okay, and the second, the launching pad. The launching pad has to be grounded, all right? After that, you play with the gravity to make sure that gravity shows proper. And because it's millimeters, we set it up to millimeters, 9.81 becomes 9,810 millimeter per second squared. The force, initially I put 10 million, 100 million pound of force, and it took us only so much higher, okay? And then I played it to billion, I changed it to billion, and it took 10 times higher distance, okay? So now at this point, what else can we do? We can make a movie out of this one. So publish a movie, click on the movie command, okay? And Assembly Beyond Mars AVI movie, okay? And we're gonna save it as an AVI. This is the only option right now we have. Yeah, so Assembly Beyond Mars and save, okay? And there are some options here, Intel IUV codec, Microsoft Video. Let's try the Microsoft Video this time, okay? Compression quality and so on, okay? And now we're going to make a movie out of this one, and we're gonna run and replay the simulation, okay? So I'm pressing the play button, and at the same time, it's making a movie. And it's going up, and it's making its own movie. And you can see it's going up. I did the same simulation activity with the 3D Studio Max. And 3D Studio Max, beyond the screen, calculations are far better because it slows down also, and it also falls back down. But here it is not falling down, and I wonder if we can manage doing this. Okay, so this is as far as it's going to go up. Okay, and finish the simulation or simply go back and stop. Okay, thank you very much for your time, and I'd like you to generate this simulation on your own. And please, please make sure you make a video, because you're going to add this video to your portfolio at the end of the year. And have a good day. Bye-bye.